The next topic is recursion. You have studied the concept of recursion in your C class also, in data structures also. So this is also very important concept. First of all, let's understand what is recursion. Recursion can be used for any function involving loops. Basically when a function calls itself, this is known as recursion. Rather than from any other function calling from from the main function, because there is no main function here in Python. So calling from another side, when a function call itself again and again, this concept is called recursion. Recursive functions act like loops that they iterate within the function to perform some operation. So there are a few points that we should know about recursion, which are: recursion can be used for any function which involves loops. While developing program using recursion, the programmer must follow some guidelines, such as there must be a key variable which will be responsible for the termination of recursion. Similarly, that we study in loops, there must be some stopping condition in loop, otherwise it will go indefinite. Similarly, in recursion also, there must be some termination condition so that it should stop at certain point. Next one is to determine the base value which the key variable has to meet to reach the termination. Just like in while loop, we should know the stopping point where the loop should be stopped. Similarly, in recursion, we should know where this function calling should be stopped, must be known to us, and this is called base value. To make sure, the key variable must approach the base value in every recursive call. In loop, as either we use I minus minus. Similarly, to reach to the termination point, we use either I plus plus or I minus minus. Similarly, in this recursive function, we should write a certain statement like this: it should approach to the termination condition. And in the next one, to make the recursive function terminate when the key value reaches the base value. So this is also like the previous points. We should make a logic such that at every step and after every iteration or after every function call, it should reach towards the base value so that the program can be stopped. So all these 4 points are very important in order to implement recursion. So let's see through an example how recursion works. Here we are going to compute factorial using recursion. The logic is same that we study in C also. Def fact n, where n is the variable for which we are going to compute factorial. If n is 0, then return 1. Otherwise, return n into fact n minus 1. So this is the logic, because factorial is the reduction of number in every call. Suppose if I'm going to compute factorial of 5, first it will compute factorial of 5, it will be put over here into factorial of 4. Then in the next iteration, it will be 4 f, because fact n minus 1 is call again, it is going with 1 less value. Next time it will be this, third time it will be this, next time it will be this, and in the last call it will be this. So this is the sequence in which factorial will be called. And when I have written over here in the previous statement, when n is equal to 0, then return 1. That means 1 will be returned over here. Then 1 into 1, which will be 1. So this one will be returned over here and it will be replaced with f1. That means it will become 2 into 1, which will be 2. This 2 will be returned over here. This is called backtracking. Then 3 will be 3 into 2, which is 6. 6 will be returned over here, f3, 4 into 6, which is 24. This 24 will be returned over here, 5 into 24, which is 120. So all these statements are backtracking. In recursion, backtracking is performed in order to compute factorial. So this is this is one sequence in which this number is approaching towards its end, which is 0. You can see that. And here, after returning the values, we are getting the result, which is 120. And then after completing the function, return 120 will be executed and the result will be returned from where it was called. You can see here in the function call, num input enter a number, num int num, we have converted it into integer, and then result fact num. Here we are passing fact 5. That means 5 value will be assigned to function definition, and the concept which I have written over here, it will compute the factorial of the number 5 which is given. And after computing, it will display the result over here, which is 120 in case of 5. And in case of 6, it is 720. So this is how we can compute factorial of a number using recursion. You can see the logic once again. Let me show you. Def fact n, if n is equal to 0, then return 1. Otherwise, return n into fact n minus 1. So this is the statement which is approaching towards its end by reducing the value of n in every iteration. Again, this will make call to its definition in every step. You can see that it will go over here, and every time it check n is equal to 0, then return 1. But this will not work, and it is going to repeat the same step again and again until n becomes 0. So this is the main logic of recursion and how to compute factorial using recursion. This is very important concept, and the logic is same that we have studied in C also. The concept is mentioned over here also, which I have told you. This is in expanded form. Here we have computed factorial of 6. So this is how it is going to compute the factorial. You can take screenshot of this in order to understand it later on. Now, advantages of recursion. What are the advantages? Recursive functions divide the problem into smaller similar fragments and then computes them. So it is very clear in functions, we divide the problem into small modules and then compute it. So this is the same advantage that is for functions also. The recursive code looks precise and cleaner as compared to using loops. Sequence generation is simpler in recursion, such as Fibonacci series as compared to that of loops. In some cases, we prefer loops, or in some cases, we prefer recursion. So it depends on our need. It is not like we can say recursion is better than iteration. Both can be used. It depends on you. But we should know that recursion is somewhat slower than iteration. Next, what are the disadvantages of recursion? Recursive code is hard to develop and debug as it involves huge complexity. The logic of recursion is always complex as compared to loops. So it includes huge complexity. So it is somewhat difficult to understand. Recursive functions are expensive as numerous calls occur within the function, which takes up a lot of memory, space, and time. Whenever we call a function, it takes a lot of consumption of memory. You can say that we use stack. Internally, it uses stack when a function call occurs. So it takes a lot of memory space in the form of stack when we use recursive functions. Recursive functions are slower as compared to iterations. I already told you, because it has to make call again and again. That's why they are a bit slower as compared to iterations. But there are certain problems which can be solved only by using recursion. So in those cases, we have to prefer it. Like for quick sort, we need to use recursion. For heap sort, we use recursion. Fine, there is radix sort for which we use recursion. So there are certain problems in which we have to prefer recursion as compared to iteration. So this is all about recursion in Python. The concept of recursion is same in every programming language. Now, what is scope and lifetime of a variable? There are two kinds of variables. One is global and other is local. Local variable, like in the sum function or in the product function which we have studied early, A and B. We have declared A and B and we are using it. So these are in the local scope of this product function. This is called local variable. And global variables which are declared outside all the functions and they can be used by all the functions in a program. Those functions are called global function. Those variables are called global variables. So there are two kinds of variables basically, global and local. Let's see through an example. We have declared a variable val is equal to 0, then def scope val, and we are going to print it. And in the function call, we have given 10 and print val. You can see that when this value goes here, it prints the value 10 over here. And when we are printing print val, it prints 10. That means here it is local and here it is printing global value. So this is all about local and global variable. We have declared value 0 globally over there. That's why it is picking 0 value over here and it is printing 10 value in the local scope. I hope you understood all the concept of recursion and local and global scope also. And in the next lecture, we'll study modules. Okay, students.